For thousands of years, us humans have been thriving on top of the earth. For over generations of our existence, I firmly believe that this is the best age to be alive. From the beginning of all of humanity till now, the rate of growth is truly a spectacle. From grand innovations like Falcon 9 to quantum technologies, I feel though we are closer than ever to me having an affordable yet a compatible computer that can actually download Minecraft without it freezing. The topic of which I have developed a great amount of interest in is quantum computers. What are they, and how is all this possible? And after all the research, I'm glad to say I managed to scratch the bare minimum surface of this technology. Basically, I'm an expert now. But jokes aside, I'm glad to dig deeper into reading how this technology works. But as of the current state of right now, I can only explain the vast field in the most basic standards with 16-year-old vocabulary. So what are quantum computers really? Well, through my expert deduction, I found that quantum computers are actually just computers that utilize quantum properties to operate. Developed by Alan Turing in 1930s, the properties of which that make up a quantum computer enhances its capabilities to an extent beyond even that of a supercomputer. So how does it work? Well, that's a good question, Tyler. That's why you're the best. A quantum computer has a few steps to its operation, the base of which all begins on a small plate with an electron or two ions that are given the status of a qubit. A classical computer uses binary to input and output, which are just patterns of ones and zeros. So what a quantum computer does the same is outputting the signals with ones and zeros, which are emitted from an ion or an electron when it spins. So how do they spin? Well, for starters, I found that ions don't actually spin, but are just turned up and down, up being 1, down being 0. The plate produces electric fields that stop the particle from colliding, and it also leaves them facing down. The temperature of a quantum computer is also kept at 4 Kelvin, or minus 269 Lamel.15 Celsius, to eliminate excess energy that could potentially ruin the operation, and to preserve the superconductor magnets at their prime state. Superconductors? That's right. These superconductors are what keeps the ion spinning, the frequency of which needs to be projected at a very precise measurement or there will be errors. The specific frequency is found by an equation that I won't specify because I can't explain it. In a qubit, the wave is directly targeted to affect the ion A, since ion B is directly associated with ion A's magnetic pulses, which could interfere with ion B's metamorphosis. Ion B is shot with a second beam of wave, if necessary that is. Now this part is what I consider to be the most significant part of the quantum computer. The part where it makes a quantum computer. And that is superposition and entanglement. This is where the rules that I like to call making sense no longer applies. To sum it up, a superposition is when an ion is given a specific frequency of a wave that will leave the ion in a state of neither 1 nor 0. The weird part is, this could somehow leave the ion in a state called entanglement with other ions. Let me explain entanglement with the best of my 16-year-old knowledge. Essentially, what I have taken in is that entanglement happens when two or more ions are in a state of superposition, and they're like forced to kiss and stuff. And if the process is successful, and the entanglement is secured, whatever happens to one of the ions will be directly associated with the other ions that it is entangled with, no matter the distance. And apparently, this all happens simultaneously, going faster than the speed of light. The one thing that makes complete sense to me is why they call it entanglement. Such a sad fate for the ions. But save your empathy, because it doesn't last. It's very fragile, like my ego. That's why you just pump up a bunch of these ions very fast to entangle them. Though they force love upon the ions at a rapid speed to get the quantum computer going, this entanglement does work very efficiently though. It really speeds up the process, and in a very large scale too. I mean, it's making cash, so morals don't really matter anymore. It also seems that Einstein also didn't really like the idea that much either, which definitely brightens up my massive ego. Now this is a video that shows that has like the basic ideas of what a quantum computer does. And I'll just play that.
An ion is a charged atom. Here we see two of them, a calcium and a strontium ion. They are superb, controllable quantum systems, and we'll see we can store information into either one. Suppose our strontium is initially in state 0. We can apply a pulse of energy to switch it to state 1. Later, for readout, we can use a laser that would have no effect on state 0. But our ion in state 1 will absorb energy and then emit it back as a photon, a particle of light which we can detect. Let's zoom out. We see gold strips below. These produce electric fields, holding our ions still without physically touching them. And again we see a laser causing an ion to become excited and emit its photon. Zooming out further, we see the gold strips are part of a small chip called an ion trap. And then we see surrounding electrical and cooling systems. A final zoom reveals the entire system is encased in a vacuum chamber which protects it from the atmosphere. Surrounding the vacuum chamber are laser systems, field coils, and crucially a photonic link system to capture the photons into an optical fiber. This complete module is a small quantum processor, but now consider two linked modules. When photons meet at the entangler unit in the middle, the ions that created those photons become quantum entangled, and so the two modules combine as a single quantum machine. Extending this idea, we can have an entire array of modules. We can switch connections so that a module links either to a nearby neighbor or to another far away. In this way, we can have a highly connected and scalable quantum brain.
Yeah, so please don't let this guy's awesome voice overshadow mine. My voice is pretty cool too. So, anyways, so knowing all this, the most important question is, so what? What if they made a quantum computer? How does it change my life? Well, there are many big practical uses of a quantum computer. For example, the best use of this technology is definitely to flex my big brains upon other people. It makes me feel like a deity that's looking down upon my pawns, showering them with forbidden superior alien knowledge, which I'm not saying is untrue already. I'm just joking. I do that regardless. The real use of a quantum computer lies deeply on its ability to calculate in a speed that is the square root of the speed of a classical computer. This could be very efficient in finding something on a large array, but from my knowledge and creativity, I can't really think of anything else. Maybe the scientists would somehow make it affordable in the future. Who knows? If it comes with a massive shed, maybe I'll get one in the future. But as of right now, a quantum computer for its cost to build one isn't really the most practical technology right now. It's fragile, not cost efficient, and it looks like a massive chandelier. Sure, it can find stuff faster, but at what cost? Though I'm talking smack, I do believe in the scientists. They have done a lot over the generations, finding stuff that were thought to be impossible. It's amazing how much we can achieve by knowing stuff like 1 plus 1 equals 2. The new discoveries of today never cease to amaze me. They can pull something out of their big brains for everything, and this is why I believe that this is the best age. There is always something to be looked forward to. Thank you.